Hi, this is Mr. Max. So what I'm doing today is I'm going to do a few questions, about three of them, on finding the maximum or the minimum value of a quadratic function by any method, right? Including expressing the function ax squared plus bx plus c, which is the quadratic function from standard form into vertex form. And then we're going to do a bit of sketching, all right, using the turning points and also the intercepts. Right, so let me just go directly to a question. So this question says that this particular graph here shows the graph of y equals to x squared minus 4x. And then you can see that the graph passes through the origin, all right? And it crosses the x-axis at point A. So the first question that we want is for you to find the coordinates of point A. Now what you do in order for you to find the coordinates of point A is, because we need to know where does the graph, or what is the value there where the graph cuts the x-axis, right? And that equation of the x-axis is nothing but y equals to 0. So I'm going to take my function and I'm going to let it equal to 0. So as an equation, it's x squared minus 4x equal to 0. And what I'm going to do is I'm going to factorize, because I have got two terms. All right, so I know that x equals to 0 is one solution, which is the origin, but I'm looking for the other value, so therefore x equals to 4. So the coordinates of A then is going to be the point 4, 0. Now, a second question here is that they ask you to write down the equation of the line of symmetry. So there are many ways you can do it, but what I'd like to do is, because I know what the x-intercepts are, I'll just average them out. So that means I take 0 here plus 4, all right, and then I divide that by 2. So I know that my line of symmetry should be halfway between 0 and 4, which is x equal to 2. Ultimately, you can also use your formula x equals to minus b over 2a, which is the formula for the x's of symmetry, all right, and identify the value of b, which is negative 4 in your function, all right. You still end up with x equals to 2. Right, so let me bring my grid back, and they're asking me to find the coordinates of the lowest point here. So essentially what they're asking is, they're asking me to find the turning point that is here. So I know already the value of x is 2 from my previous work on the line of symmetry. So I take then that 2 and I sub it into my function for x in order to get the output value, or the lowest y value there. So that turning point there, or the lowest point, which is a minimum, okay, that point is 2, negative 4. 2 for the value of x and negative 4 for the value of y. Now, this particular question is very interesting. It says that there is a point on the graph besides the point 0, 0, where the x and the y coordinates are equal, and we need to find that point. So when x and y are equal, when I say x is equal to y, then I can substitute in my equation here, I can substitute this value of y, nothing for x, because they are saying x is equal to y. Okay, so when they are equal, the coordinates, whatever x value is equal to the y value, I can then say, okay, let me take out the y and substitute it by x, and now I'm going to have an equation. So I'm going to solve this particular equation. So I'm going to solve it by moving that x over. So when I do that, I clean it up, I get to x squared minus 5x equals to 0. Now, the way that you solve this quadratic equation here, because it has got two terms, is we need to take out a common factor, which is x. Right? So we know that x equals to 0 is already a point, which is the origin. So the other point has to be x equals to 5. Right? But the question wants us to find the coordinates of that point. And the coordinates of that point is going to be when x equals to 5, then y equals to 5. Because at that particular point, they have to be equal. So whatever x is, my y will be the same. It's the same as when x is 0, y is 0. Right, so there's another question here, and it says that you are supposed to find the coordinates of the point where the gradient of the curve is 0. Now, the gradient, if we quickly have to go back and talk about the gradient, when a line slopes in this direction, the gradient is positive. So I can see that the gradient will be positive here. All right, so we want us to find the point where the gradient is equal to 0. So it can't be lines that slope in this direction. So the gradient will be equal to 0 if the line is a horizontal line. Okay, and that particular point then has to be the same point like our turning point, because at that point, the gradient of the line is 0. Right, so we have a second question here, and they are saying this diagram here shows a sketch of y equals to x squared plus 1, and you can see this sketch does not cut to the y-axis, so it's essentially the graph of y equals to x squared, and that has been translated upwards, all right, by 1 unit. So this is actually 1 here where it crosses the y-axis, and then we have a line here with a negative gradient. The line is y equals to 4 minus x. So they are saying we're supposed to write down the coordinates of point C. Now, it's very straightforward to find the coordinates of point C, because you can look at your equation. When you make x equals to 0, and the idea there is to find the y-intercept. So if x equals to 0, then y equals to 1. Okay, so there is not going to be a value for the x-intercept, because you can see from the sketch here that the function does not pass through the x-axis. So the particular coordinate point that we're looking for is the point 0, 1, and you can see here that the positive 1 here is the y-intercept, and where it cuts the y-intercept, there's no particular value for x. Right, so let me bring that diagram back again. Now they ask us to find the coordinates of the point of intersection of y equals to 4 minus x. Now they want to find where it cuts with the x-axis as well as where it cuts with the y-axis. So it's that straight line here, and where it cuts with the x-axis as well as where it intersects with the y-axis. So when you want to find the y-intercept, you make x equals to 0 in your equation, and you realize I have got y equals to 4. That means that's the point 0, negative 4. And the same applies when you want to find the y-intercept. You make x when y equals to 0, all right, that is going to allow us to find the x-intercept, all right, and we realize then that the line will cut the x-intercept at 4, and at that particular point y is 0. So the 2 points we are looking for is 0, 4 at the y-axis and 4, 0 at the x-axis, because you can really see that the gradient here of this line is -1. That is 4 divided by 4. Obviously it has to be negative because of the slope of the line. Now they're asking us to find the gradient of the line. So just take this formula and rewrite it in gradient intercept form. Y equals to mx plus c. Obviously you can see, as I indicated there in blue, that the gradient is nothing but -1. Right, let me just bring the diagram back again here. And this question, you have to be a little bit careful. They're asking for the range of x values. So from x values, what values of x will the gradient of this graph, if we draw a gradient, will it be negative? So when the gradient is negative, all right, and if I bring here, lines have to slope in this direction. So I can't have a line that goes in this direction, because these lines, the gradients are going to be positive. So I can't be looking at values of x, all right, that are positive. I can't be looking at values of x that are greater than 0. Remember, at where it's 0, the gradient is equal to 0. So I'm looking for which values are the gradients going to be equal to negative. All right. So when I draw, for example, a gradient here, this line will have a negative gradient. Okay, it will have a negative gradient. Let me bring another one here, this blue one here. If I were to draw at that point, it will have a negative gradient. So that tells me all the x values are negative, but not 0. So that means values of x that are less than 0, like -1 and so on, or -0.5. As long as it's not equal to 0, because the gradient with the gradient of a horizontal line is equal to 0, but we're looking for negative values, so it's going to be any point where x is less than 0, that means negative numbers. Now they are saying that the two graphs, they intersect. Remember, we know the graph is y equals to x squared plus 1, and the straight line is y equals to 4 minus x. So the only thing you do is you equate them, because where they intersect, they are exactly equal. All right, and then you just clean this up and write it in gradient intercept form, or in ax squared plus bx plus c is equal to 0 format. All right, and then you see I do arrive at that particular answer. So what they want us to do here is we need to solve this equation. Now remember, I have done plenty of videos on how to solve quadratic equations. All right, so because they are saying the answer is supposed to be rounded to 2 decimal places, that means we need to solve this either by completing the square or by using the quadratic equation formula. Right, so I'm using completing the square here. So the first thing is I move that -3 to the right, it becomes a positive term. Then I have a little sequence of events that I like to do. All right, so I find half of the middle term, which is the 1 here. All right, and I square that. All right, and when I square that, I will be adding this 1/4 to that 3. So you see, when I get half of 1 is 1/2, and that's what I have here. So I've completed the square here on the left. All right, and in here there's a 1/4, so I must add that 1/4 to the right as well. So when you multiply out x plus 1/2 squared, when you multiply it out, you're going to get a 1/4 somewhere in there. That's why I must add also that value on the right, because it's added somehow on the left. Right, so when you clean that up, the only thing for you to do is find what is 3 plus 1/4, that's 13/4. And then what you need to do is you need to find the square root in order to get rid of the square here, the positive and the negative square root, because we're going to have 2 solutions here. All right, so the square root of 13 is irrational. That makes this answer to be rounded to certain decimal places. And the square root of 4 is nothing but 2. So the next thing is to take this 1/2 and subtract it on both sides. All right, so that's going to give me one solution of -1/2 plus the square root of 13, or -1/2 minus the square root of 13. These are my answers in third form, but they want us to give the answer 2 decimal places. So one answer will be 1.30, or another answer will be -2.30. Of course, you can also use straightforward the quadratic equation formula. You should still arrive at the same solutions. Right, the last question that I want to do here is I want to take this particular function y equals to minus x squared minus 2x plus 3, and I want to write it in vertex form, and I also want to draw the sketch. All right, and then I'm going to show the x and the y-intercept, and then I'm going to show or also get the turning point. So the first thing is I must realize that this particular graph, if I will sketch it, it will take this shape here, all right? Because the value of a is negative, it's less than 0, and so a also cannot equal to 0, because if a is equal to 0, this becomes only a linear function, okay? Right, so then obviously you can use x equals to minus b/2a, or completing the square method, in order for you to find the axis of symmetry. So when x is equal to -1, all right, so I know my graph is going to be translated, okay, to the left. All right, but when I write it in here, I have x equals to -1, but if I take it back, all right, remember the solution is x is equal to -1, but when I go back here, I'll get x plus 1 is equal to 0, and this is the stuff that we have to put inside there, okay? That is the only thing you need to be on the lookout for. Right, so now, in order for me to find the value of q now, so the value of q, because I already know what my value of p is, so the value of q, my value of p is 1, my a value is -1, you can simply see that from the function. So I take that -1, I plug it for x into the function, and that gives me 4. So now I have rewritten my function from this form into vertex form. I can also deduce the turning point. It's going to turn at the point -1, 4. So that is the turning point of the graph, and it also tells me that the graph will have a maximum because of that shape that it takes. All right, so I have the turning point, I have my vertex form. So let me find what will the y-intercept be. Now it's very easy for you to find the y-intercept. You simply make x equal to 0 into your equation. All right, and then you will realize the y-intercept is going to be y equals to 3. So this particular function or this graph is going to cut the y-axis at positive 3. So let me find the x-intercepts. And in order for me to find the x-intercept, I need to make that an equation where y equals to 0. So what I'm left is to solve this particular equation. Right, so the way you solve this equation, I have a minus here in front of the x squared. So I'm going to divide by -1 each term there. So I'm going to either divide by -1 or I'm going to multiply by -1. The property of 1 is such that when you divide a number by 1 or by -1, or when you multiply a number by 1 or by -1, it basically is the same thing. Right, so when I do that, the negative changes everything. This minus x squared becomes positive x squared, the minus 2x becomes positive 2x, and the plus 3 becomes negative 3. Obviously 0 times or divided by -1 still gives you 0. So when I'm here, I can actually factorize this particular equation to x plus 3, x minus 1 equals to 0 in its factored form. And you simply take each bracket then and let it equal to 0. And then you'll find one solution, x is equal to -3, and the other solution, x is equal to 1. So now I have got my x-intercept. I know my graph here is going to cut the x-axis at 2 places, obviously. All right, so particular graph, my graph is going to be there, and here is going to be the -3. And here is going to be the +1, and also the graph is to the left. So I expect the y-intercept to be 3, all right, and then also I can also complete my turning point. So you will see this information on the next particular slide where I have done it. I just want you to have a look at how I did the stuff so that you can follow step by step what is it that you need to do. You don't have to use complete the form, the square, when they ask you to write it in vertex form and when they ask you to write it or to use any method. But when they particularly tell you to use completing the square, I have done a video also, so if you can check through, you'll find that I have done that. So my sketch has, and your sketch has to look like this. Remember, you get 4 marks in an examination setup for your turning point, for your y-intercept, for your x-intercepts, like that. And obviously sometimes you get a mark as well for the sketch, but this is generally how this particular question is treated. So this brings me to the end of this presentation.